Hello students, welcome to the Smart World School of Complete Learning. Now we'll read about the chapter 8, which is How Seasons Occur part 2. In the first chapter you read about how seasons occur part 1. Now it is part 2 of the same chapter. So let's start. Can you tell by discussing the activity you have been carrying out since um, in the first chapter you carried out, make use of the observation tables for the months of June, September and December. If you remember, we had some table and we marked something in that related to the seasons and timings. So let's start. In which month the duration of the day was around 12 hours? What could be the reason behind it? Bring out the differences between the duration of the daytime in the month of June and September and December. What could be the reason for the change in the shadow of the stick? If you remember, we had a stick activity too. What did you observe about the position of the sun at the horizon at the times of sunrise and sunset? And which of the following factors could be related with the change in the position of the shadow of the stick and the difference in the duration of daytime? Rotation of Earth, distance between the Earth and the Sun, revolution of the Earth, and the axis of the Earth. You must have noticed the longest day, the shortest day, and the days with the same duration of day and night time with the help of the observations in the month of June, September, and December. Generally, these dates are the same every year. With the help of the shadow experiment, you must have noted the change in the position of sunrise. Let us study the changes in the position of the sunrise and the difference in the duration of day and the night time. Come to the geographical explanation. Apparent movement of the sun. You must have realized through your observations that the position of the sun at the sunrise appears to the change on the horizon every day. Its position appears to move towards the north or the south in the course of a year. However, in reality, the sun does not move anywhere. That is why this movement of the sun towards the north and the south in a year is called the apparent movement of the sun. The position of the rising sun keeps on moving towards the south in the period from 21 June to 22nd December. This period is called Dakshinayam. From 22nd December to 21 June, the sun keeps moving towards the north. This period is called Uttarayan. The revolution of the earth around the sun entitled axis of the earth are the two factors responsible for the apparent movement of the sun. Seasons occur only with the reference to the northern and the southern hemisphere. Think about in which direction will the location of sunrise and sunset appears to move after 22nd of December. Always remember, this year you will study the apparent motion of the sun in your science textbook as well. In that book, the sun's east west motion from sunrise to sunset, that is its diurnal apparent motion, is also considered. In geography, we consider the apparent north south movement of the sun. In both the motions, the sun only appears to move and does not actually move. The diurnal apparent movement of the sun is related to the rotation of the earth, whereas its annual apparent movement is related to the revolution of the earth and the tilt of the earth's axis. Observe figure 8.1 and carefully and answer. So this is your figure which is showing the cycle of seasons, equinoxes and solstices. Okay, so the first question is, how is the northern hemisphere in which you live positioned relative to the sun on the dates given in the figure? Which season will you experience in the northern hemisphere around 22nd December? If you see, dates are also given to you. What would be the season in the northern hemisphere around 21st June? If it is winter in the northern hemisphere, which season will it be in the opposite hemisphere? At any given point of time, why are the seasons in the northern and the southern hemispheres different? Perihelion and aphelion positions of the earth. The path of the revolution of the earth around the sun is elliptical. The sun is at one of the two centers of the ellipse. The sun does not change its position as the earth moves in an ellipse. Its distance from the sun does not remain the same. It is at its minimum distance in the first week of January. This is called the perihelion position of the earth. In this position, the southern end of the axis is towards the sun. As against this, in the first week of July, the earth is at the farthest point from the sun. This is called the aphelion position. In this position, the northern end of the axis is towards the sun. With the help of figure 8.1, which shows the position of earth in relation to the sun, you can guess which season prevails in the which hemisphere. Seasons occur due to the revolution of earth as well as due to the tilt of its axis of rotation. Do you know, due to gravitational forces of the sun and the earth, the speed of earth gets reduced, and during the aphelion position and increases during the perihelion position. As the difference in the distance of the earth in both these positions is not very great, it does not have any effect on the seasons. Coming to graphical explanation, as the earth revolves around the sun, the equator receives perpendicular rays on 2 days in a year. This condition occurs on 21st of March and 23rd of September. On these days, both the poles are at the same distance from the sun. This is called equinox. If you can see in the figure 8.3, the North Pole, the South Pole, Arctic Circle, Tropic of Cancer, Equator, Tropic of Capricorn, and Antarctic Circle, and the sun in the right. The illuminated and dark portions of all the parallel, including the equator, are shown in figure 8.3. See, in the figure, the circle of illumination divides all the parallels from the North Pole to the South Pole equally. Everywhere on the earth, night time and daytime are of equal duration. This condition is called equinox. On equinox, the sun rays are perpendicular on the equator. In this condition, the circle of illumination coincides with the great circle defined by two opposite meridians. In the northern hemisphere, spring prevails from 21st March to 21st June, while autumn prevails from 23rd of September to 22nd of December. The southern hemisphere has the opposite seasons during these periods. In the northern hemisphere, 21st March is called spring or vernal equinox, whereas 23rd September is called autumnal equinox. The equinox or solstice dates can vary by a day or so. Using our brain power, on equinox days, the two poles experience either sunrise or the sunset. On which pole will it be sunrise on 21st March? Figure 8.4 shows the position of Earth with its tilted axis on 21st June and 22nd of December. It also shows its illuminated and dark portions. Observe the figure and answer the following. See, this is the figure 8.4. The position of the Earth with its tilted axis on 21st June and 21st September. It is the first one is of the 21st June and second is of the 22nd December. And in between showing the sun rays towards the figure A and figure B. So the questions are, in figure A, which pole is receiving sunlight? In figure B, which pole is not receiving sunlight? Which hemisphere has the longest daytime? Which hemisphere will have the longest night on the 22nd December? On which date will the Tropic of Cancer receive perpendicular sun rays? Considering the position of the North Pole, which seasons will prevail in the northern hemisphere from 22nd March to 23rd September? The cricket matches in Australia are generally in summer. When does Australia have summers? In which period is the midnight sun observable in Norway? Which season will be there at that time? At what time will the midnight sun be visible at the Bharti Research Station of India at Antarctica? And what will be the season there at that time? For the geographical explanation, When any one of the poles inclines the most towards the sun, 23 degree 30 radian parallel of that hemisphere receives receives perpendicular sun rays. If you see in figure 8.4, the sun rays are perpendicular at the equator on 22nd March and 23rd September, which are the days of equinox. After 22nd March, other parallels between the equator and the Tropic of Cancer in the northern hemisphere start receiving perpendicular rays sequentially. On 21st June and 22nd December only, the sun rays become perpendicular on the Tropic of Cancer and Tropic of Capricorn respectively. These 2 days are called solstice days. Sunrays are never perpendicular on any of the parallels between Tropic of Cancer and North Pole between Tropic of Capricorn and the South Pole. 21st June is the longest day and it marks the shortest night in the northern hemisphere. Similarly, 22nd December marks the longest day and the shortest night in the southern hemisphere. 22nd December is the shortest day in the northern hemisphere. In the region from the Arctic Circle to the North Pole, the sun remains visible for 24 hours or longer. At the North Pole, the sun is visible in the sky from 22nd March and 23rd September. That is for 6 months. Similar situation prevails in the region between Antarctic Circle and the South Pole. This Similar situation prevails in the region between Antarctic Circle and the South Pole in the period from 23rd September to 21st March. Note that on the equator, the duration of day and night is same throughout the year, that is 12 hours each. Seasons have been decided on the basis of the duration of sunlight, equinoxes and solstices. The equatorial region does not experience any change of season, hence the climate in that region does not change at all in the year. It places beyond the equatorial region in either hemispheres. Summers or winters are experienced one after the other. Within a year, the occurrence of the seasons one after the other in a year leads to the cycle of seasons. Generally, there are 2 seasons, summer and winter on the earth. However, in some places, seasons are taken to be 4 in all. The changes in the atmosphere, vapor in the air, the wind and the precipitation also influences the seasons. Continuous occurrence of the rain in a specific period give rise to an additional seasons besides summer and winter. And due to the local conditions, seasons other than summer and winter are seen to occur in different parts. For example, rain occur in India in a specific period. Therefore, we consider 4 seasons such as summer, the rainy season period, the period of retreating monsoon and winter. There are 4 seasons in Europe and North America too. There are summer, autumn, winter and spring. The cycle of season and the living world. If the Earth's axis were not tilted, the same climatic conditions would have prevailed throughout the year and the seasons would not have occurred. One and the same type of climatic conditions would have prevailed on each of the different parallels. It is the tilt of the axis that leads to occurrence of seasons, change and diversity on the earth. The living world on the earth is affected by the cycle of seasons. For example, in the region between 66 degree 30 radian and 90 degree in both the hemispheres, even the mild sunlight available for a part of the year gives rise to the certain flora and fauna. In the Antarctic region, at the southernmost part of earth, birds like penguins, fish like seal and animals like walruses are found. In the polar region of the northern hemisphere, animals like reindeer, polar bears, arctic foxes, etc. are found. People living in this region too have adapted to the natural conditions prevailing in that region, and our adaptation to climatic conditions is possible only up to a certain limit. That is why organisms prefer a certain habitat. During extreme cold climatic conditions, when the food supplies become scarce, a number of birds and animals migrate temporarily. Trees bear fruit in a particular season. Therefore, agricultural seasons also depend on to the local climatic conditions. Use your brain to find that while India and England are located in the same hemisphere, why are the cricket matches in these two countries arranged in different months? On 21st March and 23rd September over the earth, September daytime and nighttime are same all over the earth, but why do some parts experience summer and some parts winter on these days? And lastly, mention any two countries in the world where one needs woolen clothing in the month of May. Also mention their latitudinal positions. See the two pictures of Arctic tern and Siberian crane. And do you know, once the winter at the North Pole becomes severe, the bird travels southwards. When it is summer in the northern hemisphere, it flies back towards the North Pole. It has to travel in search of food. In the course of 1 year, it travels around 70,000 kilometers. It might be only the species in the world that experiences summer twice in a year. Due to severe winter and lack of food, cranes from the cold northern regions visited India, traveling around 8 to 10,000 kilometers. Once summer starts in India, they migrate back to the north. Think about what effects do the seasons have on the biodiversity in India, and write briefly about it. Give it a try that regarding daytime and the cycle of seasons, what conditions would have prevailed at the following places. If the Earth's axis were not tilted, use the globe to answer the following questions. And the places are Canada, Tasmania, Nigeria, West Indies, Peru, and Borneo. Think that the summer capital of Jammu and Kashmir is Srinagar, and the winter capital of is Jammu. What could be the reason that this there are two capitals in two different seasons? Okay, now let's come to the exercise. The first question is about completing the statements using correct options. The first is the apparent movement of the sun means. Option A is the sun revolves around the earth in a year. Second option is it appears that the sun moves to the north or south in a year. And the third is that the earth keeps on changing its position. Choose the option. The second point is if the axis of the earth were not tilted, then option A, the earth would not have rotated around itself. Option B, the earth would have revolved around the sun with greater velocity. Last option is different parallels on the earth would have experienced the same climate throughout the year. Third point is 21st June and 22nd December are solstice days. That is option A, the sun starts its southward journey from Tropic of Cancer on 21st June and northward journey from Tropic of Capricorn on 22nd December. Option B is the Dakshinayan of the sun takes place between 21st June and 22nd December, or the last option is the Uttarayan of the earth takes place between 21st June and 22nd December. Fourth point is the revolution of the earth around the sun and the tilt of the axis of the earth together are responsible for the following seasons. Option A, summer, rainy, retreat of monsoon and winter. Option B, summer, winter and spring, and option C is summer or winter. Question 2 is about following answering the questions. Question 1, what leads to the occurrence of seasons? Question 2, what is the duration of the day on equinox? Question 3, why is the effect of the seasons not experienced in the equatorial region? Question 4, why is the sun visible for more than 24 hours during Dakshinayam in the region between Antarctic Circle and the South Pole? And question 5 is, why are the penguins not found at the North Pole? Question 3 is to rewrite the following sentence after correcting them. So here are few sentences for you which might be incorrect and you have to correct them and write. First is the earth's velocity varies according to the period of evolution. Second, if we observe from the northern hemisphere, we see the apparent movement of the sun. Third, the dates of equinox change every year. Fourth, North Canada experiences summer from September to March. Fifth, when it is summer in South Africa, Australia has winter. Sixth, duration of daytime is less on the vernal and autumnal equinoxes. So read the sentences and the sentence which you find incorrect, correct that and write. The fourth question is about spotting the error in the diagram given below. So here is a diagram for you. Notice, see it and spot the error. You will get this from the chapter 2. Question 5 is about drawing a diagram showing the cycle of seasons in the southern hemisphere. Okay, so here comes to the end of your chapter. Read the chapter, understand the concepts, and answer the exercise. Thank you.